Hello everyone. In this particular session, I'll be explaining a simple code which finds greatest common divisor of any two positive number. This GCD is also known as HCF, that is nothing but highest common factor, and GCF, which is greatest common factor. When I tell greatest common divisor, if you consider a number 48 and the number 18, okay, we are trying to find the largest number which divides both the numbers exactly. That is, if you consider the number 48, we know these are all the numbers which can divide the number 48, and now if I consider the number 18 are the numbers which are perfect divisors of the number 18. If you compare the list of numbers here, the greatest number which is common in both is nothing but 6. So 6 is known as the greatest common divisor of the given two positive numbers 48 and 18. The very first thing you should know is what exact logic is used in this particular code to find the greatest common divisor. And the answer for that is subtraction-based Euclidean algorithm. Okay, so how exactly does this Euclidean algorithm work? So let me give a simple example for that. Let us take the same numbers 48 and 18 and let's understand how this Euclidean algorithm works. Let me take these numbers here 48 and 18. Let me perform subtraction. What is the result we get? Answer is 30. Now take the result, subtract this number with the smallest number available here. Okay, so which one is small here? It is 18. And what is the result you obtain here? It is nothing but 12. Continue the subtraction. 12 is one term we are considering, and the smallest among these two is 18. Okay, and the result we obtain is 6. Now next step, what will happen? If you consider here, the lowest among this is 12 minus the result, you get the answer as 6. Now if we notice here, the lowest number we have, okay, and the result we have obtained are actually equal. This number itself is the answer we are searching for. That is the GCD of 48, 18, or the greatest common divisor for the number 48 and 18 is actually equal to 6. This logic applies for any number considered here which is greater than 0. Now let's implement this particular logic here and see how it works. Area is an assembler directive which defines a section of memory in order to store this particular instruction, and that section of memory is named GCD program. Okay, code indicates we are just storing instructions and not data. Read only because we don't want any changes to happen to this particular information during runtime. Entry indicates where exactly execution starts, that is it starts at the very first label that is seen after this particular assembler directive, that in our case is nothing but start. First two instructions loads decimal value 48 and 18 into registers R0 and R1. Here you have to load the numbers whose GCD is to be calculated. Okay, and the final result will be stored in both register R0 and R1. So this GCD loop is again a label. In the loop, the first thing that happens is comparison. We compare if R0 and R1 are equal. We do this because if R0 and R1 are actually equal, that itself is the result that we are searching for. Okay, so we'll branch to stop. If that is not the case, we'll perform the actual subtraction. That is, here in this particular case, since value are 48 and 18, internally subtraction happens due to comparison. That is 48 minus 18 happens. The result is 30. Okay, but compare doesn't store the result. Instead, it updates the CPSR register, that is the conditional flags of CPSR based on the result. Okay, and from the result, it's very clear that Z flag will be set as 0 because the result is not 0. Okay, and as of now we don't have to consider other flags. Okay, we'll go here, we'll see the condition that branch if equal to stop. This will work only if z is 1. Okay, but because z is 0, it will ignore this particular instruction and moves here. So once this particular branch instruction is ignored, the next instruction we see here is subtraction. Okay, both the statements here are subtraction only. Here R0 minus R1 is performed and the result is stored in R0, and in this statement R1 minus R0 is performed and the result is stored in R1. Only one of this particular operation will be performed, okay, based on which exact conditional code becomes true. Okay, let's understand this particular conditional code now. GT is nothing but greater than. Okay, it performs signed comparison, and hence this particular instruction will be executed only if z flag is actually 0. Along with that, if negative flag is actually equal to overflow flag. Okay, what does it mean? Either both negative and overflow flag must be 0, or both negative and overflow flag must be set as 1, and this happens only if R0 content during this particular comparison is actually greater than R1. And let's assume this condition is not true. Okay, then this instruction is not executed. Instead, the control moves to the next instruction, and the result of subtraction that we see here is stored in R1, but only if the condition LT is true. This particular case, LT refers to less than. Okay, it is also a signed comparison. Okay, so what is checked here is if n is not equal to v, that is if R0 is actually less than R1. In that particular case, R1 minus R0 is done and the result is stored in R1. Okay, so this is the logic that we notice here. And what do you mean by n not equal to v? Negative flag should not be equal to overflow flag. Only in that particular case, this particular subtraction will occur. Once either of this particular operation is carried out, branch happens back to this particular loop, and this loop continues until both R0 and R1 are stored with same value. Okay, so once it becomes equal, we branch to stop, which is an infinite loop. And here is an assembler directive which indicates the end of source file. Now since we understood the logic here, let's see how it works. Okay, so as we can see here, there is no error in this code, so we will go ahead with the debugging. Okay, so we have loaded the value 48 and 18, which are decimal values, into register R0 and R1. 30 and 12 are hexadecimal equivalents of 48 and 18 respectively. Okay, so the first thing happens here is comparison. Let's carry that out, and the comparison causes the flags to get updated. As you can see here, R0 is actually greater than R1, so carry flag is set as 1, all other flags are set as 0, and this particular instruction is ignored because Z is actually equal to 0. So now either of the subtraction should be carried out, but from what we can clearly see, 48 is greater than 18, so this particular subtraction happens and this is ignored. Let's see that happening. Okay, and as already told, the subtraction happens if Z is 0 and n is equal to v. Okay, that condition is true now, because of which R0 minus R1, which is nothing but 48 minus 18, will be stored in R0. 1e is the result that we obtain. 1e is nothing but hexadecimal equivalent of decimal number 30. Okay, now let's just continue here. This particular instruction will be ignored because in our case R0 was greater than R1, and we are branching back to the loop. So here again comparison happens between which two value? Between 1e and 12. Okay, so if you notice here, again the first value is greater than the second value and result is not equal to 0, so this branch is actually ignored. Okay, and out of these instructions, which one will be executed? This instruction will be executed, because again arg0 is greater than arg1. Okay, so subtraction happens and result C is stored in arg0. Okay, and what about this particular instruction? It will get ignored, and we are branching back to the loop. Now when you compare again, as you can clearly see, arg1 is greater than arg0. Okay, so branch will anyway not occur. Okay, but instead the first subtraction is ignored and the second subtraction is carried out. So now we are branching back to the loop. Okay, again we are comparing these two values. Okay, when you compare, what you notice is nothing but arg0 is greater than arg1. Again result is not 0, so the very first subtraction occurs, fine, and next subtraction is ignored and we branch back here. Now when comparison is done, arg0 and arg1 are holding same value, so we are branching to an infinite loop which is stop. Okay, so as expected, a value 6 is noticed in both arg0 and arg1, which is nothing but the desired value for our number 48 and 18. Okay, that is nothing but the desired greatest common divisor for the numbers 48 and 18. Okay, so that's all about this code.